Today we're doing linear programming, and linear programming isn't, not talking about like computer programming or anything, okay? You won't need really books today because I'm going to go through the definitions with you. Okay, I want to make sure everyone gets the title and the page numbers down. I'll give you a minute to get that taken care of. All right, so linear program. What is linear program? What is objective functions? What are restrictions? Well, there's linear programming. Linear programming identifies conditions that make a quantity as large or as small as possible. That's going to be our goal today. To make a quantity as large or as small as possible. This quantity is expressed as an objective function. Okay? Limits on the variables in the function, the objective function, are called your restrictions. All right, I'll give you a second to kind of copy down what you want out of that, but I'm going to explain in more detail using this example here. Okay, so if I'm looking at this example, what you're given are a bunch of restrictions. These restrictions are based upon this function. Okay, these restrictions we have, in this case, 1, 2, 3, 4 restrictions. Okay, notice they're inequalities. What's been done here is these restrictions have been graphed on here. They've been shaded, and there's an overlapping region right here. Okay, so when you're dealing with linear programming, you're graphing some restrictions. Those restrictions then you will form a region for, and that region has vertices to it. Okay? Those vertices you then test in your objective function. That's kind of the process. So I have 4 vertices that I test in this thing called an objective function. Now, objective functions usually are dealing with profit or cost. So when you're dealing with linear programming, it's really you're looking for a maximum profit or a minimum cost. Like if you're in business, you usually want to maximize your profit. Otherwise, you're probably not in business too long. That'd be sad. If you lemonade stand and stuff. Anyone do lemonade stands anymore? Nick, okay, and Chance, yeah. Together?
Sometimes.
Okay, all right. So that's what we're doing today in a nutshell. The only thing I haven't shown you is that you have these big story problems that you do, which actually help, that you have to pull the restrictions out of, and the objective function that help you find the maximum profit or minimum cost. Okay. Everyone tell your neighbor which restriction this line is. Which of these 4 restrictions? Tell them what it is and why. Which one is it? First, second, third, or fourth?
First.
Cody.
First.
First? Everyone who agrees it's the first? How do we know? Go ahead, Jaden.
Because the slope is 3 over 2.
Slope is 3 halves, yeah. We're here, rise 3. Oops, excuse me. We're like here, rise 3, 1, 2, 3, run 2. There we go. 3 halves, I lost myself there. Okay? You could also look at the y-intercepts, -3, right? Y-intercept on this one is?
7.
7. Well, that's 7. -3 has to be down here. These are just vertical and horizontal lines. -3 would have to be down here. Okay. All right, well, let's try some of these. We're going to take baby steps. Your assignment today on your worksheet, remember, due on Monday, but it's all on the example side. We're going to be working through some together. And on the mixed side, it's 3, 6, and 10. All on example, 3, 6, 10 on mixed. Okay? Now, usually what students do is they're like, oh, pictures. Yeah, you can do those. Oh, dude. Oh, man. I got to like read and do math. And then they're really bumming about these. And then they turn it over and they're like, oh, picture. Oh, I don't even get to do pictures. But, oh, dude, I got 2? 2? Sheesh. Okay, well, just so you know, Monday you have your whole assignment is story problems. In fact, let me pause. All right, so on number 1, I want you to read through the instructions real quick on your own. Okay, so find the values of x and y that maximize or minimize the objective function for each graph, or on each graph. Also, find the maximum or minimum value. So you're looking for 2 things. You're looking for a coordinate, and you're looking for a value. Okay? Now pay close attention to instructions on these. Now I know teachers say that all the time, because they want you to read them, but you really have to pay attention to what they're asking for when you're doing these. Sometimes they'll just say, what are the values that maximize the function? Sometimes they'll say, what is the maximum value? Sometimes they'll say, what are the values and what is the maximum or minimum? This time they're asking for both. First thing you need to do when you're given a graph like this, notice they've given you the graph. That's nice of them. You don't have to plot any restrictions. They've done it for you. We need to first label the ordered pairs. Okay, you get 30 seconds. Okay, the ordered pair for A, one of our easier ones, 0, 0. For B, 0, 4. For C, 2, 2. And for D, 1, 0. All right. Okay, I'm assuming everyone can label those ordered pairs, but what I'm going to do is I'm going to write those coordinates down here. Let's zoom in on that a bit. Okay. All right, I'm going to list my point A is at 0, 0. My point B, 0, 4. And C, 2, 2. And D, 1 and 0. What I want to do is I want to test those points. I want to find out which ones maximize my profit. Okay? So P stands for profit. Usually C is cost. You want to minimize C, maximize P, usually. Okay? So in this case, I'm just testing points. 2x plus y. Well, x isn't x. It's actually now 0. So that's actually 2 times 0. Plus y, which isn't y. It's actually 0 as well. 0, 0. That gives me a profit of?
0.
0. That's not good. All right. If P is equal to 2 times x, or 0, and plus y, or 4 in this case, because we have the ordered pair 0, 4, we get a profit of? 4. Two times 2 plus 2 equals 6. And 2 times uno plus zippo is
2.
2. What is my maximum profit?
C.
Eli?
C.
It is coordinate C, which is how much? What's the value?
$6.
$6. So my maximum is at the ordered pair 2, 2. That's the value of x and y that they're asking us for. And it's equal to, in this case, say, I guess it's, we don't know that it's dollars, but we're saying 6. Okay. Tough?
Not yet.
Not yet. That's the right answer. Not yet. It's a little more complex. Any questions on there so far? Now I'm going to take baby steps, so don't get lost along the way. If we don't get this, you can't do the next couple things. Yeah.
Couldn't you just kind of tell by the graph that it was going to be C?
Yeah, you could guess. It could have been that one. I mean, look how close they were.
Well, if you the equation, just looking at it, C has 2 numbers, everything else has 0.
Yeah, but if your y value is more valuable, right now x is more valuable, right? The rate for x is more valuable than y. But if these were switched, then that one would be worth more, right? So it just depends. It's easy to tell minimum sometimes. Like if they said find the minimum, we wouldn't do any math. We just 0, 0. Can't get any smaller than that in quadrant 1, right, Craig? Dude, seriously, you get it?
Yeah.
I know. All right. I admire those too. They're pretty good. It's the Hawks. I know. Okay, here we go. Number 2, everyone give it a go. Put in your notes. All right, let's see how we did. So, on number 2, we went through, we labeled the ordered pairs. Point A is at 0, 4, point B is 0, 6, C is 5, 6, and D is 3, 2. We plug in those values, right? 3 times 0, 2 times 4. Plug in your x, y's for your objective function. Now this time they're asking for a minimum, right? So as we go through, our minimum value is 8 at the point 0, 4. Okay? So I put minimum at 0, 4 That's equal to 8. All right. How many got that? So do you have to find a max and a min every time?
No.
No, just follow what they're saying. If it says minimum, find the minimum. If it says maximum, find the maximum. Okay. Everyone rate themselves 1 to 5 right now. All right, we're about to take it one step further.
Oh, no.
Turn up the heat.
No.
Here we go. Take a look at number 4. Any last minute questions? Last chance on these. Yes, Nick?
So the answer would be just the min or max, and then the at the point, and then the what it equals to. That'd be the answer.
Yep. Min 0.4 at 8. Okay, number 4. Directions here. Graph each systems of restrictions, then find the maximum or minimum value of the objective function on the graph. All right, well now we don't get the graph. We have to make the graph. And then we have to go through all the steps. So I'm adding a step for you. Only because I like you though. Okay? All right. So, first thing, and I'll give you guys give you an opportunity to work here in a minute. Just pay close attention for a minute. When you're graphing these, if you do not like using the x and y intercepts, that's going to make your life a lot more difficult at times, especially in this stuff. X and y intercepts, when x is 0, that's your y-intercept. When y is 0, then you have your x-intercept. Okay? Now I've given you grids like this. Notice I purposely did not label the x and y axis. Okay? That's because sometimes you may have to go out further than 10. If you don't label a value here, it's assumed that you're going up by 1s. So like if you wanted to go up by 2s, you could count out to here and say, okay, that's 20, and now you've defined that interval as 2. You're going up by 2s. You don't have to label every single one. Okay? When I'm looking at this, if I put 0 in for y to find the x-intercept, what is that? 5. X plus 0 is, and I'm just kind of thinking to myself, x plus y equals 5. I'm ignoring the inequality, but when I put 0 in, I get x equals 5. That gives me a point at 5 on the x-axis. How many points do I need to graph a line? 2. So there's the x-intercept. I could easily find the y-intercept. It's when x is 0, which is 5. So if I go 1, 2, 3, 4, 5, I put a point. I now have a line. Is this a solid or dashed line looking at this?
Solid.
Solid. All right. So I'm going to give you a chance to go ahead and do that. Make sure you're accurate with your lines. Okay, so remember the way we figure out where we shade here, we could plug in 0, 0. 0, 0 is right here. So if x is 0 and y is 0, 0 plus 0 is less than 5. So is 0 less than 5?
Yes.
Yes, that means we shade below that line. Now I'm just going to shade that portion of the arrow just to make my graph a little less messy. I'm shading towards 0, 0. Y is greater than 1. Well, where is y 1? Everyone show your neighbor where y is 1.
Right there.
It is.
Okay. So y is 1 right here. Now notice that's this line where my pencil is. That's y is 1. Okay, so I'm drawing a horizontal line where y is 1. Now it says y is greater than 1, so am I shading above or below? Where are the greater values, up or down?
Up.
They're up. Okay, so I just shade those arrows there. All right, and x is 2. Where is x2? Show your neighbor there. And so x is 2 right there. Okay, so we've got our vertical line now. Okay. Now, with that, am I shading the greater values or the lesser values?
Lesser.
The greater, right? Because it's a greater than symbol.
I was guessing.
Don't guess. Unbelievable. All right, now you're looking at your arrows. I've got arrow, arrow. I've got shade, shade, no shade. So it's not this region. I've got no shade, definitely not that one. I've got shade, no shade, and shade, that's not good. I've got shade, shade, and no shade. Okay, I've got shade, shade, and shade. So shade to the right of that, above that, and in on that one. Okay, you can do those little arrows like that in any part if you want, but that shows me that this is the region I'm shading. There are a lot of different regions that appeared there. Notice this one, this region I have shade up, I have shade down, but when I look at this line, I have shading that way. So away from that. That doesn't work here, so I don't shade that one. I only shade where there's all shading. And what that does, what does that let me do now?
Can you have one of them pretty fast?
Yeah, it lets you find your points. Okay, so now we're back to the type of problem, to this type of problem right here, where we're testing our points. So now we have the graph and we can test points. So we have our graph now. Now you need to list your points. The ordered pair 2, 3. The ordered pair 2, uno. And the ordered pair, what do we got? 4, uno. Eli.
If you're doing the dark side on the arrows, do you have to do it on both sides or just one? Or do you care?
You mean here and here?
Yeah.
I don't care. Yeah.
Do you need variables like A, B, and C?
You don't have to, no. You can just list the points. So you can just say that's 2, 3, that's 4, 1, and 2, 1. You could just do it like that. Okay? And so with 2, 3, my cost equals 2 times 2 plus 3 times 3. For 4, 1, set it up. My cost is equal to 2 times 4 plus 3 times 1. And then 2 times 2 plus 3 times 1. 4 and 9 is 13. 8 and 3 is 11. And 4 and 3 is 7. So we're minimizing cost. So in this case it says find the maximum or minimum value. So do I need the coordinates? No. My minimum value is equal to
7.
7.
Do you do the at sign or just equals?
It's not at a point, right?
Oh.
Yeah. So it's just minimum equals 7.
That's it?
That's it.
That's a lot of work for 7.
Any questions? Okay, everyone rate themselves 1 to 5 right now.
12 and a half.
Okay.
12 and a
Okay. So the next piece is the joy. Any questions before we move on? Remember, we started with the picture. We tested points. Now we made the picture and tested the points. Now we are going to take a look at this page. This is on the back of your note page. You turn your note page over. You have problem number 10 off the example side of your assignment. So now on this one, you don't have any of the points. You do not have the restrictions. All you have is a scenario. You need to come up with the restrictions, which will help you, once you plot them, it'll help you find the points, which you then can test into an objective function you have not been given. So in other words, you get to do it all right here. Now, Mr. Vogel and I have put together this amazing table here that seems to help out. We think it's amazing. You may not think it's amazing. And I've given you one copy of it. This is the copy. Okay? So you will then need to duplicate it, if like maybe make your own table or own version of it for the next problem, number 10 on the mixed side. And then when we do these next Monday, you'll want to use this type of format, at least this organizational skill, to help you out. Okay, right now I want you to read the amazing story of lotion here. Okay? All right, let's see. Suppose you make and sell skin lotion. Yay for you, except for Jocelyn. She doesn't like it. A quart of regular skin lotion uses 2 cups oil. That's what the C stands for. Good job. For those of us who didn't know, seriously, that comes up every year. And 1 cup cocoa butter. A quart of extra rich skin lotion contains 1 cup oil and 2 cups cocoa butter. You will make a profit of $10 per quart on regular lotion and a profit of $8 per quart on extra rich lotion. You have 24 cups of oil and 18 cups of cocoa butter. How many quarts of each lotion should you make to maximize your profit? What is the maximum profit? Now, for some people right now, your head's spinning. You're like, are you serious? There's a lot of numbers and stuff about lotion that I really didn't know and probably don't care to know. Okay? So, the first thing you need to find out, any problem, anytime you're doing a story problems, you should find out what they're asking. What are your variables? What are the unknowns that they want to know? They being the almighty person of math somewhere, okay? All right, so when we go through and we look for our variables, where do you look usually? You made it all the way to 11th grade math and don't know where to look for a variable? Yes, no?
In the description.
Yeah, definitely in the problem. It's there. I agree. Okay, Eli?
By the numbers.
No. If we know the number, then we don't need to know a variable.
Oh.
Yeah. It's in the question. Where is the question? And it's not the whole thing. This whole thing's not the question. There's a question or two. Yeah.
It's the last 2 sentences in the whole paragraph.
Yes. If you, and it sounds like most of you did not know, you find what you're looking for usually at the end of the problem, which generally is the question. The question, how many quarts of each lotion should you make to maximize your profit? That's one question. What is the maximum profit? Okay, well, we know how to find the maximum profit if we have everything else. Here is what we want. There are some variables here. How many quarts of each lotion? Well, what types of lotion are we dealing with? We have lotion.
Skin lotion.
Jordan?
Extra rich and regular.
Yeah, we have regular lotion, and we have extra rich lotion. All right, so now I can start filling this in. I have some variables. My lotion is being measured by, like, it's important to know this, right? We're not just talking about regular lotion. Well, how much? Well, just like a gallon, a tub, a swimming pool full. You just swim in it.
Awesome.
It's not that. It's how much? It's a quart. Lotion per quart. Okay? Or if you want, if it helps you out, you could label it like that. Quarts of lotion. Okay? That's a QT, right? Or QRT, excuse me. Just thought it was Q. Okay? What are we going to call regular lotion?
X.
R. Good. Let's go with R. What are we going to call extra rich lotion?
E.
E. Yes. We could call it X, but I'm going with E. Yeah. X would be good. Okay. All right. Very good. So, hey, really? We're almost done. If we solve what we have, what we will have, we'll know this. But let's go back to the top. Suppose you make and sell skin lotion. Well done. We know. We don't care. Now we're just eliminated part of the story.
It's gone.
Okay? A quart of regular skin lotion uses oil and cocoa butter. What did I do right there when I read that?
Took out the numbers.
Took out the numbers. Now, it's helpful when you start reading problems without the numbers. Okay? A quart of regular skin lotion uses oil and cocoa butter. A quart of extra rich skin lotion uses oil and cocoa butter. You make a profit on regular lotion and you make a profit on extra rich lotion. You have oil and cocoa butter. Now, that may seem silly, but you should be able to tell me now what the lotion has in common. What?
Oil and cocoa butter.
Oil
Profit.
and cocoa butter.
Wait, what?
Okay? When you start taking out the numbers and you forget about that, you now can start thinking, okay, what did I keep hearing, man? Oil and cocoa butter, oil and cocoa butter. You go home today and say, you know what? I wonder if my mom's lotion or my dad's lotion or my grandpa's lotion or my grandma's lotion has oil and cocoa butter. And you turn it over, you're like, dude, It's got oil and cocoa butter. Sorry, man, you don't have cocoa butter. You don't have good lotion. Okay? I have no idea. All right. I don't use lotion. All right. So now we go back and we have to use numbers. We are dealing with this. Look, this is a grid. Regular and oil. A regular type of lotion uses how much oil? Let's go through. A quart of regular skin lotion uses 2 cups. Now that's per quart, right? So if I have 1 quart, how many cups did I use?
2.
If I have 2 quarts, how many cups did I use? 4. If I have 12 quarts, how many cups did I use? 24. If I have 50 quarts, how many cups? 100. So what am I doing to the number of, to the number of quarts?
You're multiplying it by 2.
I'm multiplying it by 2. So everyone write an expression here that says that. Okay, what do we have here? 2 times R. It's not 2 times quart, right? We've defined a quart of regular lotion being R. And we've defined a quart of extra rich being R. So maybe it would have been helpful if you would have wrote the word quart right here. I don't know. Maybe some of you need to see that. That's a quart of extra rich and a quart of regular. Maybe the quart here didn't make as much sense.
Quart.
All right. Okay, so a quart is 1 R. So if it's 2 cups per quart, it's 2 times R. How much cocoa butter per quart?
1
1 cup. So how do we write that expression?
R.
1 R. Notice there are only R's in this column because this is the R column, right? R. Okay. How about here? How many quarts of oil, how much oil per quart of extra rich?
1.
1E. Now you could just write E, or you could write 1E if you want. Okay, it sounds a little too much like Winnie, so I'm going to write E. Okay, how about cocoa butter per extra rich?
2.
2. 2 what? E. Now notice, we've read through. We've got that. We've got the quart of extra rich doing that. Dude, this problem is becoming less and less. You make a profit. Okay, now where would I put a profit?
Down there.
And there it says
Yeah, we're dealing with a profit here. You make a profit of $10 per quart on regular. How do we write that? Everyone write it and put it where it should go down here. Don't wait for me to do it. Do what you think, and then you can erase if you need to. Okay, show your neighbor.
Yeah,
Okay, I'm writing it here because I'm dealing with regular, and it's $10 per regular. How many got it? 10R. Good. Okay, you make a profit of $10 per regular and a profit of $8 per extra rich. Everyone go ahead and write 8 per extra rich. How do we transfer that to an expression? Okay, how many got it? 80. All right. And this is a profit. All right? So, we're now done with that. This equals a profit. We now have our objective function. This is how we're making money. 10 per regular plus 8 per extra rich gives us our profit. And usually you write the P in front. You put P equals, but that's okay. Dude, we're almost done. Any questions up to there? I want you to talk to your neighbors. What are you going to do with these 2 things? All right. What are we doing with 24 cups of oil? Nick?
Those are our restrictions.
Those are part of our restrictions. Where does it go up there? Cody? Under totals for?
Oil and cocoa butter.
Yeah, for oil. 24.
Oh.
24 cups of oil. Cocoa butter. 18. Now that helps us with our restrictions, right? Like, we have 24 cups of oil, which means if I'm writing a restriction using this information, the amount of oil I use for regular and for extra rich, when we combine those, cannot exceed 24. Right? If we use more than 24 cups of oil, we're out of luck, man. Someone's lotion's not as good. Got some bad lotion. That's not good. Okay, so would this have to be greater than or less than that? Or would this have to be, actually let's go with this. Would the amount of oil we use for the lotion have to be greater than or less than 24? Less than 24. Could it be equal to 24?
Yes, sir.
Yeah. Okay, I want you to write your restriction for this next one, for cocoa butter. All right, let's see. How about R plus 2E is less than or equal to 18? How many restrictions we have? Two. What if, could I have like negative regular lotion? Can I have like negative extra rich lotion? No, that means my function is confined to quadrant 1. So if I was taking a look at, let's see, I may have to find a piece. If I was taking a look at my graph, all right. So if I was taking a look at this graph, this problem appears only in quadrant 1, which means I actually have 2 more restrictions here. I have R and I have E, and there's some stuff I have to fill in next to these. 2 more restrictions. I want you to talk with your neighbor real quick. What are they? Volunteer. R. Go ahead, Nick.
Wouldn't it be, wait for the whole equation?
Yeah, for R.
R plus, wait.
Oh,
What
not
do you
R.
mean for just R?
Yeah.
What do you mean for just R?
Oh, just R. There's 2 restrictions. One that involves R, one that involves E, that limits it to quadrant 1. Gabby? Yeah, R has to be bigger than or equal to 0. How about E? Kobe? Has to be greater than or equal to 0. That automatically means it can't be negative. That's another way of saying, hey, these can't be negative. Okay? All right, so those are your 4 restrictions. We're going to graph them on this grid. Now, that being said, you have 2 of your restrictions already graphed because I've given you a quadrant 1 graph. Unless you turn it like this, now you have a quadrant 4 graphs. Sorry. But we're going to keep it like this, so now it's a quadrant 1 graph. All right. Quadrant 1 graph. Okay, and when you're dealing with quadrant 1 and you're dealing with your y and your x, usually your x is your independent, y is your dependent. However, with regular lotion and extra rich lotion, is there an independent and dependent? No, one type of lotion does not depend on the other. So it doesn't matter what you call what. If you want to call that R and that one E, that's okay. If you want to flip them around, that would be okay. The thing you have to start figuring out is, first, how many lines do I have to work with on, in this case, E? It's like 1, 2, 3, 4, 5. Okay, I got like over 30. Okay, that's good. And here, got about 28. Okay? Why is that important? Well, because when I'm doing this, remember we've already graphed these. I mean, just by virtue of what we've got here, right? We know it's in quadrant 1. But this one right here, what is my R-intercept?
12.
R-intercept when E is 0, R-intercept is 12. Okay, so I'm just going to put R equals 12 here. That tells me my R-intercept. Okay, what's my E-intercept?
24.
It's 24. Here, what's my R-intercept?
18.
18. It's when E is 0. And what's my E-intercept?
9.
It's when R is 0. Good, it's 9. Okay? Now, if that's the case, I've got to get up to 24 on E. Do I have enough room to go by ones? Yeah, I do. And I have to get up to how far on R?
18.
18. Do I have enough lines?
Yep.
Yeah, so I could go by ones. Now, there are going to be times when you say no, and you're going to have to count by twos or fives or tens or hundreds. Okay, or thousands. There'll be some that you have like that. When I'm doing this, now I can plot my intercepts. I can draw my restrictions. And I can find my points that I test in my objective function. Okay, so that's what you're working on right now. All right, so there's mine. I haven't shaded it yet, but that's what I have. Okay, crosses at 9 and 24 on E, right? 9 and 24. And then I had my 12 and 18 for R's. Okay, so 12 and 24. 12 went to 24. 9 went to 18. All right, my shading appears to be this area right here. Okay, and I know that based upon testing 0, 0. They're both shading down. Looks like this is my other point besides this point. Okay, so when I'm listing my coordinates here, I have a 0, 0. That's one vertice. I have a 0, 12. And I have a 9, 0. And I have this one here, which happens to be, looks like 4 and 10. Is that right? Okay. What's our next step?
Test them and such.
Yeah, we have to take our objective function here, 10R plus 8E equals our profit. Okay? And we've got to test those coordinates. We've got to test 0, 12, 4, 10, 9, 0, and 0, 0. Now, which one do we know we can rule out if we're looking for max profit? 0, 0. 0, 0 is going to give us 0. We know that this one is not going to work. Our profit is 0. But this one is 10 times 0 plus 8 times 12. Oops, did I do that backwards? Yep, so 0 goes with E, sorry. So this should be 0. So this is my E, this is my R. Okay. All right, or 120. 10 times 10 plus 8 times 4. Or 100 plus 32. Then 10 times 0 and 8 times 9, or 72. So our profit is here. That's 4 extra rich. Oh, time to go. And 10 regular. All right, you guys have your assignment. Here we go. Remember, this is not on your quiz tomorrow. Have a good day. Super swell day.
Super swell day, no way.